Welcome to This Explainer. Today, we're stepping right into the high-stakes, meticulously choreographed world of industrial plant construction logistics. If you've ever wondered how sprawling refineries, power plants, or massive manufacturing facilities actually come together without descending into total chaos, well, you're in the right place. We're going to focus on a hyper-specific, absolutely crucial phase of construction preparation, the delivery status check. It might sound like simple administrative work, but as we're about to see, it's literally the beating heart of a multi-million-dollar operation. To get us started, I want you to think about something we literally all do. You order a $10 phone case online, and suddenly you find yourself obsessively refreshing the tracking app, right? You want to know the exact second it leaves the warehouse, when it hits the local hub, and exactly what time it's hitting your porch. We do this for the absolute smallest, cheapest items. Now, hold on to that feeling, and imagine magnifying that anxiety and that need for precision by a factor of about 1,000,000. Because there's a huge difference between a $10 package and a $10 million piece of plant equipment. Your online order? Low stakes. It arrives whenever, the delivery driver just tosses it at your door, no big deal. But industrial equipment? It has to arrive exactly on schedule. The financial stakes are astronomical. And, most importantly, you can't just drop it off. It needs a massive custom-built concrete foundation waiting for it. It's kind of like opening a huge global burger franchise. You order this state-of-the-art, custom-built industrial grill. If that massive grill arrives before the kitchen floor is even poured, it's just going to sit outside and rust. But if the floor is ready and the grill is delayed, you can't open. You're just bleeding money. Timing is literally everything. Okay, let's dive into this core conflict. Picture a massive pressure vessel hanging from a crane, ready to be installed. Now picture the specialized concrete foundation designed specifically to hold it, complete with anchor bolts sticking out. Here's the catch. In a plant construction project, totally different teams handle these two things. The mechanical construction team is in charge of installing that massive vessel. The civil construction team, they're in charge of building the concrete foundation. The problem is, the civil team doesn't just naturally know when the mechanical team's equipment is actually scheduled to arrive. And that brings us to what we call the foundation disconnect. Unless the mechanical team actively shares their delivery schedule and formally requests that foundation to be built by a specific date, the civil engineers are just going to work on their own timeline. I mean, they have thousands of other tasks to do. If a mechanical engineer just assumes the civil team will magically have the foundation ready the exact moment the truck rolls in, they are setting themselves up for an absolute disaster. The equipment arrives, there's nowhere to put it, heavy transport trailers are stuck renting by the hour, and cranes are just sitting idle. Silence between these departments literally costs millions. And honestly, that delay is never isolated. It triggers a catastrophic chain reaction across the entire site. It's a total domino effect. If just one piece of equipment is delayed, or if it arrives but can't be installed because the pad isn't ready, the dominoes start falling. First, equipment installation halts. Because it's not in place, the piping team can't connect the pipes. Because the pipes aren't connected, the electrical and instrumentation teams can't run their wiring and sensors. The whole thing grinds to a halt. A single piece of delayed equipment can literally paralyze the entire subsequent construction sequence. The financial reality of these delays is staggering. In the plant construction industry, schedules are sacred, mostly because of something called LD, or Liquidated Damages. This is a massive contractual financial penalty. If the engineering, procurement, and construction company misses the final completion deadline, they have to pay the client a pre-agreed sum for every single day they are late. And we're talking tens of thousands, sometimes hundreds of thousands of dollars per day. No wonder construction engineers are ruthlessly protective of their schedules, right? So how do we actually prevent this? How do we track our $10 million package to avoid those crazy LDs? Well, the ultimate solution is the procurement status report. Think of this as the most highly detailed, high-stakes pizza tracking app you have ever seen. It's usually issued on a weekly basis by the procurement team, and it tracks the lifespan of every single piece of equipment from the drawing board all the way to the moment it hits the dirt at the construction site. For a construction engineer, this document is an absolute lifeline. And this brings us to the golden rule for mechanical engineers. Amidst all the complex data, the part numbers, and the vendor codes on that massive spreadsheet, you must always watch the site del date. Site delivery. That is the exact estimated date the equipment will physically arrive at the job site. This is the date you take straight to the civil team. You tell them, hey, my equipment arrives on this site del date. I need the foundation poured, cured, inspected, and perfectly ready at least a week before this. To really master that site del date, though, you kind of need to understand the milestones that lead up to it. Now, for a beginner, looking at these acronyms is like reading a foreign language. But once you break them down, it's really just the logical life cycle of heavy machinery. You go from technical bid evaluation to purchase order to fabrication complete, estimated time of departure, estimated time of arrival, and finally, site delivery. Let's break these down real quick. It all kicks off with TBE, the technical bid evaluation, and PO, the purchase order. Going back to our burger franchise analogy for a second, TBE is the phase where your engineers rigorously check the specs of the grill from the manufacturer. Does it run on the right voltage? Are the dimensions exactly right to fit under the exhaust hood? They're evaluating the technical merits. Once it passes all that, they issue the PO, the purchase order. This is the official contract. It's basically swiping the company credit card and saying, yep, build it. Next up is the paperwork and fabrication phase. Before cutting any actual steel, vendors send over their detailed engineering blueprints. These are marked as vendor prints received and approved. Once the heavy machinery is actually physically built, it's marked as fabrication complete. But it doesn't ship just yet. It absolutely has to pass rigorous quality control checks before it can leave the facility. That's marked as inspection complete. Only then is it boxed up and ready for its global journey. Now we get to the really tricky part, ocean logistics. You're going to see ETD and ETA. ETD is the estimated time of departure. This is when the equipment is loaded onto a massive cargo ship and actually leaves the foreign port, say leaving a port in the US. ETA is the estimated time of arrival, which is when that ship hits the destination country's port. Now here's a little extra context because it's absolutely vital. The gap between ETD and ETA is heavily subject to unpredictable variables. Typhoons in the ocean, congestion at the destination port, sudden customs delays, any of these can push your ETA back by weeks. A seasoned engineer knows that an ETA is written in pencil, not ink. So, the crucial point here is that after the equipment survives the ocean voyage, clears customs, and is loaded onto a multi-axle heavy transport trailer to be driven to your actual construction site, that is your site delivery. This is the moment of truth. And because of all those variables we just talked about, the site del date on your weekly report is going to fluctuate. A strong construction engineer monitors this report every single week, communicates any shifts immediately to the civil team, and ensures that the concrete pad is waiting, perfectly cured, and ready to receive the load. To wrap up this explainer, I want to leave you with this thought. Preparation isn't just about reading blueprints. It's about mastering the clock. You could be the smartest mechanical engineer in the world, perfectly understanding the internal workings of a complex pressure vessel. But if you can't read a procurement report, anticipate shipping delays, and coordinate with the civil engineers to pour a concrete foundation on time, your brilliant equipment is just a very, very expensive lawn ornament. So I leave you with a provocative question to ponder. What exactly happens in those critical hours, the moment that multi-million-dollar equipment finally drops onto the foundation? How do we align it perfectly, down to the millimeter? Well, we'll just have to explore that fascinating phase next time. Thanks for joining me on this explainer, and keep mastering the clock.